In our experiments, we evaluate several baselines according to multiple criteria. Field distance, which measures the diversity of our sampled points. Hypervolume, which is a standard optimization criterion. Number of positive points, how many samples meet the constraints. Coverage recall, which is the area induced by our sampled points. Finally, we also did many experiments across multiple domains. Here we show the results of the additive manufacturing example, which is a fair representation of what you should expect from these methodologies. Our method, ECI, excels at finding diverse configurations that meet our constraints. This can be seen by the excellent performance on coverage recall and field distance. As expected, Bayesian optimization consistently improves the hypervolume, but isn't as effective at finding diverse configurations. In the same way, active search, which greedily maximizes the number of positive points, performs best at this metric, but the samples are not diverse. Feel free to pause the video here to learn more about the baselines. Finally, we provide a summary of the main contributions of our paper. Please check out the full version for more details. Thank you very much.